You're on.
All right. Hi, everybody. Thank you so much for attending Balticon 55. I'm Dr. Caitlin Ahrens, and today I'm going to be chatting about the fantastic geologies and where to find them through the solar system. Now, a few of you have already gone through a certain presentation earlier about volcanoes, and so we're going to actually talk about a little bit about space volcanoes, but also just kind of go through a very quick tour of the solar system. By all means, I wish I had like 5 hours with you lovely people today, because there is so much weird geology out in space. But let's go ahead and jump right to it. All righty. So Earth we use as our own personal background, playground, if you will, with our planetary scientists. So most of us kind of scatter throughout the world. We tend to go to Hawaii and Iceland for the volcanoes, or even down to Canada and Antarctica, because they're actually the best analogs for Martian conditions because they are considered dry deserts. Now, keep in mind that deserts don't always mean sand, but it just means dry, arid plains of a certain material. But considering all the kinds of weird geology we have on Earth, we have volcanic systems, whether some of them are dormant or very, very explosive. You can have dunes. You could have different kinds of rock formations bending and cracking and being slanted at different angles. You can have the beautiful arches. If you've ever been to arches out in the Western United States, it is gorgeous. There's also very active fault lines, fault systems all over Earth as well. Quick announcement here real quick though, is that I will get to questions. Please put them in the chat if you can, and I promise I'll try to get to as many questions as I can at the end of the presentation, because there is a lot of pictures to show you guys through the solar system. Oops, well. Oh, there we go. But the other weird thing about we use for Earth and then try to figure out all the weird geology in space is to figure out what in the world is going on with some of the weird geology here on Earth as well. So as you can see here, you have certain mountain formations uplifting from certain continental plates, and then you have the bending of rocks. And so you're combining physics, you're combining chemistry, maybe a little bit of biological sense to this as well with other planets. I'm personally an astrophysicist and a geologist, so this is certainly my cup of tea, is how do rocks bend? But first we're going to start with our lovely first planet of the solar system. This is Mercury. Now, the thing about Mercury is that nothing against people who love Mercury, but I think it's honestly a boring planet. Sorry. But the really cool, weird part about Mercury, though, is that we have these puddles of lava, but there's no actual volcanic structures on Mercury whatsoever. So what we think may be happening here is that Mercury is instead bleeding, where you would have these small micrometeorites essentially puncturing the surface of Mercury over and over and over again, to the point where the underlying goo of Mercury essentially floods the basins and craters, and then it solidifies. So this is essentially scab wounds on Mercury, which we lovingly call smooth plains, but let's be honest, scab wounds on Mercury sounds so much better. Onward to our second planet here is Venus. Now, if you squint your eyes and tilt your head, you may be able to see the surface. No, I'm kidding. Venus here has immense cloud systems, though. So we actually didn't know what the surface of Venus was well into having the Magellan missions in the 60s and 70s. And so we had a radar system, same radar that we would plunk down into the oceans and map out our sea floor. Someone had the brilliant idea to strap it onto a rocket, orbit it around Venus, and we see the beautiful surface. Now, Venus is not rainbow. I wish it was. But this is instead an elevation map. So the pink and white that you see here are the very high up places, high elevation places, and then the darker blues and purples and blacker colors are the lower elevations. But from this image and then all the way around, we were actually able to count over 400 volcanic systems on Venus, and we're still counting. Now, whether they are still active is still under debate currently, but Venus also has some very bizarre volcanic systems as well, which we call pancakes and ticks. So here's pancakes, where you have material essentially bubbling and then oozing. So they're very much like pimples, but that sounds gross. I guess not as gross as Mercury and scabs here. But in this case, the material bubbles up and creates a pancake here. And then sometimes those pancakes become so large that it crushes the surface underneath it and it forms faults right underneath the pancake. And the faults look like little legs sprouting out of the pancake, in which case we call these ticks. So it does look like a giant bug on the surface of Venus here. Onward to the moon real quick. Now the moon I can chat about for hours on end. The moon is certainly very, very odd as far as its geology goes. Gorgeous, gorgeous geology in that case. And I'm happy to answer any more questions about the moon. But the moon here is Earth's natural satellite. It has some beautiful mare. So mare is actually Latin for oceans there for a while. And it's honestly not that hard to the imagination that the really dark patches here, you would kind of think that they may have been oceans. In this case, they are technically oceans, just not flowy, liquidy oceans. They are oceans of lava. And then sometimes you can have rills, which are also lava tubes. These rills are very interesting that they may honestly house future astronauts. So that's actually being explored currently. Sometimes you could also skylights as well. So these are caves, planetary caving, planetary spelunking. Just became a new branch of planetary science as of 5 years ago, I believe. And so that's become a very entertaining branch of planetary science, to say the least. Because can you imagine that to be your job title? I'm a planetary spelunker. Well, good on you, I guess. Hippity hopping all the way to Mars here. Goodness gracious, Mars I could also talk about for hours on end, but Mars certainly does have some interesting and weird geology as well. First and foremost, it has the largest volcano in the entire solar system. It is humongous, so round of applause to Olympus Mons here. So Olympus Mons, the base of Olympus Mons is just a tad bit smaller than the state of Texas. So it roughly more comparable to the state of Arizona. So it is massive. And if you see in the middle here, you notice that it's not a nice round little circle of a vent in this volcanic system here. These are actually what's called nested calderas, which means that this volcano would have erupted from a vent and then sealed itself and collapsed. And then it would have exploded again, seal, collapse. And it did it over and over and over again. So every time it collapsed, it would make a new caldera. So as far as I'm aware, the number is up to 8, but it might have erupted more than 8 times. And then it's just hidden and erased through geologic history though. But Olympus Mons, as far as we know, is a dormant or dead, hopefully dead volcano, but gorgeous nonetheless. Me being a planetary geologist, I look at maps like this on a daily basis. This is what's considered our updated geologic map of Mars. So, and it is freely available. You can find it through the USGS astrogeology branch. And you can download all sorts of planetary maps to your amusement as well. But every color that you see here is a different geology. And this is just Mars. It is mind-blowing how many different kinds of geology that we have here on Mars, though. Over to the left area here, this is Olympus Mons. All of this pink and tan and beige colors are the different lava fields that came out of Olympus Mons over and over and over again. So it takes up a good portion of the Martian surface here. But Mars also has an array of other weird kind of geology too. We have chaos terrain, which makes us geologists kind of smack our head against the desk over and over again, because this is why we call it chaos terrain. It's just a mess. It is an absolute mess of just rocks jumbled up against each other, and we still don't have a good idea as to how. How are they jumbled up? Why are they different shapes, and why are they jumbled differently? There are only a few of them across the Martian surface, so it's just kind of chaos. Come to find out, though, that chaos terrain is also found on other icy moons, including Pluto as well. You also have frozen dunes. So Mars currently is already out of its winter season. It's getting into full spring blooming season. I'll get to blooming here in a bit. But when it's winter time on Mars, it's actually really pretty because all the dune fields that you see here are completely encased in a thin layer of frost. And so it's very bright, it's very reflective with the frost. It is water ice and carbon dioxide ice. But it's just so pretty that the dunes are essentially frozen in time. It's very, very pretty. Now, springtime is now on Mars. And so when springtime arrives, we immediately know when it's springtime on Mars because we call this the spider season. So spider season has already passed on Mars, but it's so bizarre when you're seeing these beautiful white frost-covered dunes. It's so pretty. And then you see stuff like this. So this is why we call it spider season. What happens here is that nitrogen and carbon dioxide vapors are actually trapped in the ice and into the sand. Into the sandy dunes and surfaces and whatnot, and then cased over with frost, and it's just frozen there. But in the spring, all that frost sublimates, vaporizes, and so it thaws, and so all the vapor then puffs out very quickly from the sand, and it has this very immediate dark black vapor. And so all of these are like little tiny geysers of nitrogen and carbon dioxide, and they go poof, and then they look like they kind of scatter across the surface as they vaporize, and then they go away in just a couple of hours. But they just cover football fields and football fields and football fields of spiders is what we call them, though. So Mars has spiders. We already got past our spider season, though, so we're good. But also, there's a really weird thing that happens at the Martian South Pole. Swiss cheese. We do not have a good technical term at all. We just happily nickname it Swiss cheese. Now, I realize that as you're looking at the screen, it may look like all the cheese doodly looking patterns that you see here are actually popping out of the screen. They're not. It's really, really hard to train your eyes to realize that all the cheese doodly stuff is actually going into the screen. These are actually cheese doodly pits. So you have to kind of train your eyes to realize like where the sun angle is, and again, tilt your head, squint your eyes kind of deal. But again, it's only in the South Pole of Mars, though. We still have no idea how to recreate it in a laboratory. We know what kind of ice it is. We just don't know why is it only on the South Pole of Mars. It's not found on Earth. It's not found on any other moon or planet in the solar system. It's just South Pole of Mars with carbon dioxide ice hanging out, making cheese doodle patterns. The most famous one being happy face. And I kid you not, you could actually Google Mars happy face, and this is what you will usually bring up is the happy face Swiss cheese blob, which looks like a very sad cookie, one of those smiley face cookies. I hope you know what I'm talking about. I can't remember the franchise right now, but I hope you know what I'm talking about. Real quick with Ceres, asteroids are just weird in general. Ceres kind of had a bit of a weird history where it was originally an asteroid and it actually got promoted as a dwarf planet. So currently we have our dwarf planet here in the asteroid belt. Yay. So in the middle of Ceres here, you have the bright spots, which we call faculi. So faculi just means bright, unusual spot. Now, the weird and cool part about these spots, though, is that they're actually very normal. Nothing exotic, nothing woo or anything like that, as much as we wanted to. But what's weird here is that it's just table salt. It's table salt and ammonia. So the same type of ammonia that you would have in our daily cleaning products here on Earth. You mix it up, and there's other kinds of salt here on the series as well. Some of it has like magnesium, but it's certainly mostly sodium, sodium chloride salts. Now, why is it only in that particular spot on Ceres? And there's actually, I believe, 5 or 6 different faculi spots on Ceres. But why in those spots? Why are there kind of look like scratch marks associated with these salt mines on Ceres? We actually don't know yet. The Dawn mission that took all these fantastic pictures, the Dawn mission team are still trying to figure that out. There's also some gorgeous landslides. If you're really into just like the really weird landslides kind of deal, this one's my favorite because it looks like a butterfly. But what would have happened here is that you would have had one central meteor just kind of crash and then break up into 2 parts and split and make 2 other dents. And so this is kind of like a 3-part impact. And then from the sheer force of it breaking, the material from the center crater would have reacted so ferociously from the heat of the impact that it would have just melted and just went bleh into its sister craters off to the side, and it makes those lovely little landslides there. So it's really cool. We call these tongues, by the way, landslide tongues, because they actually legitimately look like shoe tongues, if anything. But Ahunamon's sad face. Ahunamon's the lonely mountain here, and it is the only mountain, tiny little mountain. It's only just a couple miles large, very tiny mountain. But why is it the only mountain on Ceres? Could it possibly be a cryovolcano, which I will define later? But think about that. Why is it the only mountain? And could there have been other mountains? And Huna is the lucky mountain that watched all of its friends die. Just poor Huna. Such a lonely, sad little planet, mountain on Ceres. Onward to Io. So Io got some attention not too long ago with a Netflix series, I believe, trying to inhabit Io. I can guarantee you every planetary scientist was screaming at that. Not a good idea to inhabit Io. This is a true color image of Io, so it is definitely a moldy cheese looking tiny moon of Jupiter. So why it's so yellow is because of all the sulfur, very, very dangerous sulfur chemicals and compounds all over the surface. So the thing about all the sulfur, though, is that it is highly volcanic, very, very volcanic. So all the little pockmarks and pimples that you see here on Io are all volcanoes, and it's still incredibly active to this day. So on the left side of the screen here, you have an image from the Voyager probes that would have passed by in the 1970s. Took a picture, and there's a beautiful eruption going on there. And then by, I believe, around 2011 or 2012, the New Horizons probe, on its way to Pluto, decided to turn on its cameras at Jupiter. It went right by Io, snapped a few pictures, and just kept going. But looking back at those pictures from New Horizons, it realized, look at that, Io got to gleam its beautiful sulfurous smile at us with more eruptions. Woohoo! And then Loki. If anybody's a fan of Loki, this particular volcano had eluded us planetary people for so long because it would erupt, and then we thought maybe it would have been like a old faithful kind of deal where it would just erupt and stop and erupt and stop, and we're like, oh, cool, there's a timing with it. And then it messed with our brains. It didn't do the timing like we thought it was, and we're like, oh, fine. So we named it Loki because it was giving us a lot of mischief in that regard. But these are what some of the volcanoes look like up close. So so they would erupt, but notice that they're not mountains. Still, they're just very much ooey, gooey, geysery. They would just completely spout out very, very hot water and sulfur into the air, and then just kind of scab over. So just gross little moon. But now we're getting into more of the outer solar system, the rest of the icy moons of Jupiter and Saturn, Uranus, Neptune, Pluto, Kuiper Belt, so on and so forth. Now we're dealing with ice. Now, when you think of ice, put it in your iced tea, keep it cold, good for you. Okay. But ice in the outer solar system is incredibly weird, because you're not just dealing with water ice. You're dealing with methane, nitrogen, carbon dioxide, carbon monoxide, ammonia, ethylene, ethene, methylene, acetone, nail polish remover. Yeah, there's acetone ice out there. Does some really weird stuff. So imagining how ice, just regular old water ice here on Earth, can bend and form mountains and volcanoes and fault systems and dunes on some of these icy worlds. So real quick through some of the other icy moons of Jupiter, though. So we have Ganymede here. Unfortunately, Ganymede is sorely ignored, but does have some really pretty pictures from whenever we had an orbiter around Jupiter back in the early 1990s, which was Galileo. So Galileo and some Voyager images, but Galileo gave us our up close and personal images of Ganymede here. So we call these railroad tracks. So these are just very fresh, bright streaks of ice kind of deal. This is Cypress-Sulky. So Cypress-Sulky here is a weird scallop-shaped thing. It's a depression, but how it's formed is actually still under debate. We may think it may have been some sort of geyser at one point, and then it just kind of sealed itself shut, but still unfortunately ignored. Though Europa, however, is gaining a lot of attention. So Europa, gorgeous moon, all sorts of the striping that you see here, all this ruddy stuff that you see here. It's not iron, it's not rust. From here on out, there's no more iron. Iron is gone. So all the red stuff that you see here is actually methane, and there's other kinds of ice that will change colors depending upon how much radiation there is. And around Jupiter, there is a lot of radiation. So no surprise to us that some of this ice is very, very red. So you see some kind of fish scale textures here. This is actually one of the signature textures of Europa. So this is actually really cool. There's no technical official name as far as this goes, but there's a really fun nickname that we give this kind of process. If anybody is a fan of X-Men, we actually call this the Wolverine effect. Mainly because imagine, if you will, a meteor or comet just slamming into the surface of something that is completely icy, and it forms a hole. That hole isn't going to really stay a hole for very long, because all the slushy goo that is still underneath all the ice will immediately suck up into the hole and then freeze over. So we call this almost like a self-healing superpower with some of these icy moons. And we actually see a lot of this self-healing on other moons as well. And Pluto is starting to learn how to do that currently. So we'll get to Pluto here in a bit though. So all this fish scale stuff that you see here are actually fresher, icy, scabby stuff though. But Europa is very, very nice to have that. Ganymede isn't able to do this, and Callisto isn't able to do this either though, is because they don't actually have active oceans anymore. They may have had active oceans at one point, but it's still under debate. But Europa still has a very active-ish ocean, supposedly. So something to look forward to on a mission coming up that I will talk about later as well. But also, we just have a lot of chaos terrain. So this is the Europa version of chaos terrain. All the different types of ice just constantly scaling up against each other and over and under and around the barn. So just a mess. You also have these little domes of salt and water that would just kind of bubble up. So kind of similar to the pancake domes that we saw on Venus, just not lava per se, not hot. But Europa's beautiful ocean world cousin is Enceladus. So Enceladus, definitely some different coloring in that regard, but still very much an ocean underneath of it nonetheless. Now, one of the striking features you may see with Enceladus is at the southern hemisphere here, which we call the tiger stripes. So bright blue colors, and we just found out, I believe the beginning of 2021 here, someone took a beautiful thermal camera picture of these tiger stripes and realized that they still glow. They thermally glow. It looks so cool in the thermal images. They look bright glowy red. So cool. Now with the constant geysers that come out of Enceladus, the Cassini mission, when it was around Saturn at the time, rest in peace Cassini, at the time it was getting really, really close to Enceladus, and we honestly didn't know that it was going to erupt. These images were taken very close when Cassini was just doing a flyby. Now, the thing about Cassini being an orbiter, you can't slow it down. It's going to go through those geysers whether it wants to or not. And so whenever Cassini was getting really close to those geysers, we're like, oh, please do not melt or freeze or like bang up against Cassini. Like, please just let Cassini just go on through. Now with Cassini though, it has a nose. It can actually sniff the chemistry around the moons and Saturn. So at that point, we pretty much just turned its nose on, went right through the lovely geysers that were shooting off. And to our happy surprise, not only did we realize that they were very warm, but they also held the same water salt ratio content as that of the Pacific Ocean here on Earth. Hooray! We have confirmed that there is a very temperate, salty ocean at the bottom of Enceladus. Hooray! Now, how thick it is and just how active it is and everything, and how the heck did it even get there, still to be explored. And Titan. Oh, goodness gracious. Titan is such a weird, bizarre moon. If I had to place the weirdest moon in the solar system, it would more than likely have to be Titan. So Titan is possibly a captured planet. Think of it this way, though. Titan, as large of a moon as it is the only moon that has an atmosphere. It has its own climate systems. It has clouds. It has oceans, it has lakes, it has beachside fronts, it has dunes. It just has a whole weird cacophony of geology here. So real quick though, here's some of the beaches here. Here's an island, which we called Magic Island for a while, because on the left, notice that the island isn't there. And then after a couple months from Cassini images, the island would reappear and then disappear and reappear and disappear and reappear. We're like, what in the world is going on? It's magic. And so what happened here though is that it's actually an island on some sort of liquid that is actually flooding the island on a cycle. So this poor island just gets constantly flooded, back and forth, back and forth. Maybe the Titan version of Louisiana at this point. Sorry for those who live in Louisiana. So the thing about the whole island system here, though, is that what could possibly be liquid at Titan? So this is the fun part. Titan is about, well, I work in kelvins. So in Fahrenheit, it's about -300 degrees Fahrenheit on a summer day. That's a little bit cold. Water is no longer liquid at those temperatures. So what could possibly be liquid and act like water at those temperatures? Turns out it's methane. And methane we have here as a gas here on Earth. You drive by cows, you smell fresh cow farms. There's your methane. So in this case, methane acts just like water, liquid water at these temperatures. So it's fascinating that you have liquid methane that would actually evaporate and form clouds. And then the clouds would move over the land, rain, it would actually rain methane and then fill up the lakes, and then the lakes drain into the oceans again. It's essentially the water cycle, just at -300 degrees Fahrenheit and with methane. Dunes, there's a lot of dunes all over Titan, but for some reason they're only at the equator of Titan, so that's still a weird mystery there. And then you have labyrinths, which we jokingly call the ice walls, very similar to Game of Thrones. Imagine, if you will, ice walls that carry on for miles and miles and miles high into the air and form mazes. And we actually find them on Titan. We can't find them anywhere else, except there are actually very similar rock formations on Earth, usually found around Indonesia. But those are formed by completely different rock, but the formation may be the same. I'm currently on a team now looking at labyrinths on Titan. That's not my main job, but it's fun. I'm going to go through some other really weird moons of Saturn real quick. I'm not going to go through all of them because goodness gracious, we would be here forever and I don't remember all the names. So here we go then with Hyperion, the potato sponge moon. Poor Hyperion. Helene, very pretty Helene. It looks like it has paintbrush strokes all over the surface. Very pretty. Iapetus, the walnut moon. And we call it the walnut because of that really weird equatorial ridge around the center there. How it formed, still don't know. Pan and Atlas, the forbidden ravioli moons of Saturn. And you have Mimas, Mimas, which we lovingly call our Death Star moon. And then we have Dione, which we love to compare to the original Alien poster because it does look like the cracks from the egg, which is amazing. We have fun. Miranda is a moon of Uranus. So Miranda, we unfortunately call the Frankenstein moon. We call this because we have no idea what any of this geology is. But the closest thing we were able to figure out with this weird geology of Miranda is that it would have had to have been just a nice little moon minding its own business and then just slammed with something, ripped apart. But then the gravity would have pulled it all back together and tried to paste itself back together. And it did a horrible job. So Miranda, the Frankenstein moon. And you have Triton. I'm not going to go too much into Triton here because of time, but Triton does have some really weird geology, one of which is the cantaloupe terrain. Now, unfortunately with Triton, though, is that we only have, this is it. This is all the coverage we have from the 1989 flyby from the Voyager probes. So this is it. So this we call the cantaloupe terrain because of the texture. How's it formed? We don't know. Notice the pattern here. There's a lot that we don't know. And now we have all these like little dark streaks. This is the southern pole of Triton. All of these little dark streaks here are actually little itty bitty nitrogen geysers that are just kind of go poof out of the ice and then streak across the surface, kind of thing. So adorable little geysers. And then we have Pluto, gorgeous, gorgeous Pluto. I actually got to collaborate with the New Horizons team whenever it got to Pluto. So I'm very, very fortunate and lucky to have worked with such an amazing team, such an amazing PI for that mission as well. Thank you, Dr. Alan Stern. So Pluto, when it got there, before it even got there, we were all trying to figure out, like, what is it really going to look like? And we all had in our minds, we all thought it was going to look like Mercury. Boring, gray, cratered. It's just, we honestly thought it was just going to be like, it's a thing. Yay, we imaged it. Woo. But when we started getting these kind of images back from New Horizons back in summer of 2015, it was absolutely mind-blowing. And the rest of us geologists are like, well, I guess we're going to be busy for the next couple of years because goodness gracious, that's a lot of geology to go through. Now, remember what I said earlier about the wolverine technique here that some icy moons are trying to experience. This very, very large, the heart of Pluto. Everybody loves the heart of Pluto. I don't, but I'll tell you my reasoning why here in a bit. But this, the left lobe of the heart here, it's actually a giant impact basin. So this big honking ice comet thingy from the outer solar system truly just glided and slammed right into Pluto. And because of that, Pluto's internal ocean and ices reacted immediately and flooded that basin. So all of this lighter, smoother material here is actually the nitrogen, carbon monoxide, methane ice that is trying to heal itself right now. And it's still very goopy. It's still a very fresh wound. By fresh, to a geologic perspective, it is very fresh, 10 million years or less. So that may seem like, oh, 10 million years, it's so long. To a geologist, it's nothing. So it's still a very fresh wound on poor Pluto here, though. But it gave us our nice little heart, of Pluto. And then here's a lovely black and white image of Sputnik Planitia, the heart here as well. All of this darker material here, slowly slipping into the heart, the beating heart. It's so gorgeous, so beautiful. There's potentially cryovolcanoes on Pluto as well. So the hole that you see here and all of this little what we call knobby terrain all over the place here might have been potentially the lava. So this is kind of my research here, is cryo lava. So cryo meaning cold, but then when you think of lava, you're thinking fire and ash and rock and doom and gloom and squishy, fiery, blah and stuff. Well, how would ice and fire really compare to this unless you're Game of Thrones? So in this case, though, cryolava, lava in this case just means something coming out of the subsurface in either a very eruptive style, like a geyser, or something sticky, oozy, gooing out of some sort of cryovolcano. So again, water ice at these temperatures. Now we're at Pluto, negative 300 degrees Fahrenheit at Titan is way too high at Pluto. So Pluto here on a lovely spring day would be negative 420 degrees Fahrenheit. So much, much, much colder than Titan. But water ice acts just like volcanic rock on Earth. It can create mountains, it can create faults, it can create volcanoes. It can create all the same kind of weird stuff that rock would have here on Earth. And it's so fascinating. The math works, the physics works somehow. So cryolava in this case is that you would have a mixture of water ice, methane, ammonia. Ammonia is very, very important in this mixture because ammonia does not freeze. Ammonia acts just like a salt that you would put on your sidewalks and the road to keep from freezing over whenever it's wintertime. Ammonia acts just like the same way. It essentially keeps everything slushy. So think of like the inside of Pluto as being like a very slow slushy machine, very, very slow churning slushy machine of ammonia and methane. So I don't think you want to drink the slushy, but it slushes nonetheless. Tartarus gave us such a headache for a few years. Because imagine, if you will, about 2 miles high in the air, spires, swirling spires of pointy ice into the air and then at an angle. And it's like only in this one part of Pluto too. So we're like, why is it only in that one part of Pluto? Why are they spiky? Why is it methane? And just why and how? Turns out we actually have this on Earth, just much smaller scale, kind of deal. Oh, well, I forgot the image, but Google penitentes. I will type that up in the chat. Penitentes in the Andes Mountains around Chile and Argentina. There is actually smaller scale ice formations that will actually spike up and then tilt. So we pretty much guess that this is what's happening here on Pluto. Now, why is it only on that one side of Pluto? That we have no idea. No idea yet. Barre Montes. I have a personal bias with this particular glacier here on Pluto because I actually got to name this glacier on Pluto. Surprise, I've actually named 5 different things in space. So this is one of my crowning jewels of naming something in space. So Barre Montes, let me tell you guys the story of why I don't like Sputnik Planitia, the beautiful little heart that everyone loves so much with Pluto. It's actually a pit of destruction. Here's why. So imagine, if you will, this tiny little glacier here, minding its own business, much farther in the north of where it is now, just completely hanging out with the rest of its beautiful mountain side of Pluto. And then the heart, because it's churning and it's still kind of self-healing itself, all that churning starts to break apart the beaches. And because it broke apart some of these beaches, it actually broke apart Barre Montes out of its home and then scooted it down south. Now you may think, oh, that's not so bad. Okay, it just kind of scooted the glacier along. No, the problem here though is that, where's my mouse? There's my mouse. Is that you may see all these like weird little lines that you may see here on this glacier. What happened is that this glacier, minding its own business, like, oh, I guess I'm floating about on the heart now. The heart, still churning, goes, nah, I don't want you anymore, and slams it against the icy beaches, and it ripples, ripple effect across the glacier, essentially giving it battle scars. So all the little ripple marks that you see there essentially made the ice almost like an accordion effect. So this poor helpless glacier just got slammed by Sputnik Planitia. So that's why, in my head, Sputnik Planitia, the heart, is the villain of that story there. Enough about Pluto. Real quick then, with Charon, Pluto's largest moon. Pluto has 5 moons, but I'm not going to go into the smaller moons though. But real quick though, if you are a Lord of the Rings fan, the dark spot pole that you see here at the top of Charon is happily called Mordor Macula. Currently, we're still trying to do the paperwork to try to get more fun names all over Charon. So far, we have Oz Terra from Wizard of Oz, but we're in the process of having more like Star Wars and Star Trek related names. We have Kubrick Mons also on Charon as well. But I mean, you can't pass up having Vader Crater at some point. It's got to be done. So I really hope that paperwork goes through. Excuse me. That kind of deal. Okay, yeah, and so yeah, there's some weird mountains that are actually sinking on Charon. So we're actually currently looking at those right now. So real quick, while I wrap up and try to get to as many questions as I can, real quick, planetary science is going to have a huge boom of missions for you guys coming up in the next couple years. It is going to be crazy busy for NASA and for you fine folks. The beginning of June, NASA will announce its next Discovery Program mission. There's actually 4 in the running. So right now we're all at drum roll, nail biting, waiting at the edge of our seats right now of what that mission is going to be. But right now 4 are in the running. 1 is for Triton, named the Triton mission. We have the IVO, which is the Io Volcanic Observatory or Observer. Then we have Veritas and Da Vinci, which I'm not going to try to remember what the acronyms are for them, but oh wait, no, Da Vinci Plus. I forgot they added the plus, which now makes it sound like a vitamin at this point, but Da Vinci Plus and Veritas are 2 Venus missions as well. So all 4 of them are competing against each other, and NASA can only choose 1. So that's to be determined in June. But here's some missions coming up for us, though. We have the Artemis program. So far it's just solely focusing on the moon. We'll get to Mars later. But 2021 is Artemis 1. It will be uncrewed. And then Artemis 2 is going to be 2023. That one will be the first crewed mission of Artemis, and then Artemis 3 in 2024. So it's truly going to be nearly back to back. So we're doing some fast planning with that right now. Then we have the lovely Dragonfly mission. This is to the Saturn's moon Titan. It will launch in 2027, so quite a few years into the future, but a quadcopter on Titan. How insane and awesome is that we're going to have a quadcopter with itty bitty instruments on its belly, on its head, and everything. It's going to hop around the surface. So imagine a much bigger Ingenuity copter, a flying science lab on Titan. It's going to be great. And then we have Europa Clipper. Europa, a reminder, there is Jupiter, one of Jupiter's icy moons, the ocean moon. That is to take launch in 2024. So that one's going to be kind of like on the tailcoat of Artemis 3 in 2024. So lots of missions coming up, to say the least. But I'm happy to answer as many questions as I can. I just realized that there's a lot of chat stuff going on. I'm also happy to answer questions through Twitter. That is my Twitter handle there. I'm going to try to be on Discord as much as I can. Reminder there that use the channel Homeland or # Homeland -science to ask any questions that you may have. I'll try to get to you. If I still have yet to get to your burning sciencey planetary question or anything, feel free to just Google my name and feel free to send me an email to my NASA email, and I'm happy to answer any questions that you lovely people may have. But I'm going to go ahead and stop sharing so then I'm able to actually bring up chat. Oh dear. Okay, all the scrolling. I apologize ahead of time. Yay. Hello, hi. Let's see. Sheep Mountain. Thomas? What did you mean by Sheep Mountain? Did I say Sheep Mountain, or did the closed captioning accidentally say a type out Sheep Mountain at some point? Let's see. I still remember the fantastic descriptions of Earth's geology. Why I loved Aries all night in Mercury's death. Bleeding Mercury. Yes, it is absolutely gross. All those stringy bits of Venus topography, are those lava flows or rifts or ridges or what? All of the above. So Venus, the Venus crust is very plasticky. And we actually have a very long technical term for this. So get ready. It's viscoelastic plastic. Geology. It is awful to type in papers, but it's very, very fun. Viscoelastic plastic. Plasticity, to make it very fancy. Let's see. Any idea when the last volcanic explosion on Mars? That's a very good question. So we're actually still trying to figure that out. Turns out Mars did a kind of a weird geologic thing a couple thousands of years ago. We may think that the earliest volcanic eruption may have been 1.2 billion years old. If not very high number million years old. But what Mars did, which was really weird, was that it kind of changed its entire chemical composition. And we're not entirely sure what happened. We think that the climate of Mars kind of did a quick 180. And whenever you change your climate, your rock chemicals change as well. So it did kind of a weird thing where all the rocks were very a different kind of silica, and then 180 now it's a completely different kind of silica. And it's like, what happened? What happened there? Let's see.
Time's up.
Okay.
Time's up.
Okay, so time's up. Oh, Eaton Park smiley cookies. Thank you. Thank you to that. All right, so I will end that there with Eaton Park smiley cookies. Happy to answer questions on the Discord channel, and feel free to tweet me or to email me as well. But thank you guys so much. I hope you guys enjoyed all the really pretty pictures of weird geology through our solar system. Thank you.